Yes, hello everyone. How are you guys?
Good job.
Yes, I'm also good. All right. So hope everything's fine and the screen is visible and I'm audible and visible to everyone.
Yes.
Okay. So let us start the class. Everyone has joined. Okay. So in the previous class, we were talking about types of combustion right now. So there are various types of combustion. There are different types of combustion that takes place around us. Namely, there are three types of combustion that we are going to learn about in today's class. So, for example, the type of combustion in which heat and light are released in a very short span of time, that is called as a rapid combustion. That we call this that we call as a rapid combustion. So combustion is going to be very fast in the case of a rapid combustion. Immediately heat and light will be released in such a combustion. Is my voice properly coming to everyone?
Yes.
Okay.
Yes,
Then
sir.
spontaneous. What kind of combustion is this? The the type of combustion reaction which occurs on its own without the help of any external energy, without the help of any external energy. The combustion on its own is an example of spontaneous. Like many times, coal dust in coal mines, due to that, it can catch fire right now. So there can be combustion due to coal dust in the coal mines. That is one such example of spontaneous combustion. Furthermore, it will be taking place at room temperature. If you were to talk about this spontaneous combustion, we get to know that this can take place at the room temperature. Room temperature basically refers to the general temperature around you right now. So spontaneous combustion takes place at room temperature, and the heat required for spontaneous combustion is produced inside the substance by slow oxidation. It's not like you are externally providing it heat. The heat is produced inside the substance by its slow oxidation. Let me tell you what happens. If you were to have the example of coal dust, what happens? The coal dust will be slowly going through the process of oxidation. Oxidation, you guys should first of all understand what is oxidation, by the way. Also, all of you are required to turn your cameras on in the class. See, what oxidation basically refers to. Oxidation basically here refers to basically refers to reacting with oxygen. If you were to talk about what does oxidation mean, oxidation basically means that you have a compound, for example, you have a given element, for example, carbon. Carbon, when oxygen attaches to carbon, it forms carbon dioxide. So thereby we see that carbon went through oxidation. Getting it? As simple as that. So many times what will happen, the substance is going through a slow oxidation process. What it goes through a slow oxidation process where it will be combining with oxygen. So this coal dust will also be going through the process of slow oxidation because it will be reacting with oxygen. Although it's not a very fast reaction, but it's a very slow reaction. Plus oxygen. Did you guys understood this concept?
Sir, can you tell one more time?
Yeah, sure. See, moments ago I was telling you about the slow oxidation. Like basically, if you to talk about like what is slow oxidation, so you might have seen things that there were several things that would be reacting with oxygen at a very slow rate. For example, uh, you have some metals, for example, you know about metals like sodium and potassium. These are the metals now that reacts with oxygen. They would be reacting with oxygen to form oxides. If they were to left in open, they would start reacting with oxygen on its own. Furthermore, there are some combustible substances. You have like diesel, you have methane, you have liquefied petroleum gas, you have petrol. they will also be reacting with oxygen, but they react with oxygen very rapidly to produce a large amount of heat and light energy. So we say that they are going through a rapid combustion where combustion is very fast. In the case of petrol, diesel, kerosene oil, they are also reacting with oxygen and the reaction is very fast. While in the case of some substances like coal dust, or you have the examples of some metals like sodium and potassium. What is special about sodium and potassium, guys? Anyone? What is special about these metals? These metals are not that much hard. They can be easily cut with a knife. Okay, now. Anyways, so the thing about metals like sodium and potassium is that they also react with oxygen at a very slow rate. So react with oxygen at a slow rate. That is also one example of slow oxidation. Okay, now. But here we have one example of coal dust. So it will be slowly reacting with oxygen. Also, reaction of any substance with oxygen is also called as oxidation. Then you might be thinking that what is the difference between combustion and oxidation? Because in that process also you are seeing in the process of combustion also what did we learn? We learned a substance reacts with oxygen. No, a substance reacts with oxygen to give off heat and light. Getting it, guys? Okay, now. But like in higher classes in chemistry, you will get to know that in the case of an oxidation reaction, there must be an atom that should be going through oxidation and another one should be going through the process of reduction. Although that's a different thing, but let us just keep it simple and yeah, just understand that it will be slowly reacting with oxygen and there will come a time when it will catch fire. Hope you guys are able to understand this. Or
Yes, sir.
for example, if you were to keep a piece of white phosphorus in a china dish, you know, no, you understand what is a china dish? You heard of
Yes, sir.
this? Like in laboratory, you might have seen this china dish. So what I'm saying that take some amount of white phosphorus, okay, and keep it on a china dish. Right now, what you will observe, without heating that white phosphorus, now it will start to burn on its own at the room temperature. Getting it, guys? What I'm trying to say? China dish. I hope I get the correct image here. Okay. Anyways, I think you guys are able to understand what I'm trying to say. Okay, now. So you take a china dish. It kind of looks like this china dish, and you take some white phosphorus in it. What you are going to observe that at room temperature, white phosphorus catches fire on its own. Did you guys provided any source of heat to this? No. Get it
No,
right
sir.
now. So at room temperature, white phosphorus catches fire on its own. So thereby that is said to be spontaneously going. That is one example of a spontaneous combustion. And the heat required to start this spontaneous combustion is produced internally by the slow oxidation of phosphorus in air. Let me write this. The heat required for this spontaneous, you guys can also write these things down. The heat required for this spontaneous combustion is coming or is produced internally due to slow oxidation of phosphorus with air. With air, basically it is reacting with oxygen. Okay, now, and the spontaneous combustion reaction that are taking place in the nature are very dangerous. Can you guys give one such example of a very dangerous spontaneous reaction taking place in the nature?
So the forest been on fire.
Forest fires, very good. Right now, this is one of the example, and that does great damage to wildlife. Uh, So forest fires can also be started by a spontaneous combustion reaction. So we have example as forest fire. Moments ago we learned about the example of white phosphorus. We had the example of coal dust that can also catch fire. In all this process, one thing is common. All of them are going through slow oxidation right now. So sometimes you might see that due to the heat of the sun or due to the spark of lightning from the sky, also spontaneous combustion can start. Like that can also be cause of forest fires. Lightning is can also be cause of forest fire. And most of the forest fires are, however, caused due to the carelessness of human beings. Most of them, like someone went to the picnic and um, they left behind the burning campfire after having a picnic in the forest, or they threw away lighted cigarettes in the forest. Right now, so that is the case with this. So we learned about rapid combustion and spontaneous combustion. Hope you guys have got these two things. The first, rapid, and second one is spontaneous combustion. Is that clear so far?
Yes,
So we learned about spontaneous combustion, that the type of combustion in which substances catch fire on their own without the application of heat. That is termed as spontaneous combustion. You have the common example as forest fire. Now let us learn about explosion. Let us learn about explosive combustion. Explosion, or basically explosive combustion. So here what you're going to see that it will be causing large amount of release of heat, light, and in some cases sound will also be produced. The most common example is of firecrackers. So explosive combustion, what is this? You see that explosive combustion is a fast combustion reaction in which a large amount of heat, light, and sound will be produced. As simple as that. Also, a large amount of gas will also be released. Huh? A large amount of gas is released quickly in an explosive combustion. Getting it? And it is the rapid combustion of these gases which causes a loud sound. Let me tell you why that sound is produced. First of all, explosive combustion. What are the features we learned about it? First thing, that this is a fast combustion. Very fast combustion reaction. Khadija, today you are having your extra class, okay, no?
Okay, sir.
And Gauri, tomorrow you will be having your extra class for the chapter materials, metals, and non-metals. Okay.
Okay, sir.
So it's a very fast combustion reaction. Another feature we learned, that large amount of heat, light, and sound is produced in such a case. Okay. Now let us learn that how sound is produced in this in this case. You will observe that, say, when a firecracker is burned, for example, firecracker, why does it produce a sound? See, first of all, when it is burning, you will see that there will be a quick release of gases. Gases will be released, isn't it? So gases are released in this case. So this large amount of gas that is released quickly in an explosive combustion, and since combustion is very fast, so thereby these gases that are coming out of it now, these gases, the rapid expansion of these gases causes a loud sound. these gases are expanding at a rapid state or at a rapid speed. Getting it, guys? So it is the rapid expansion of these gases which causes a loud sound. We have the example of fireworks like crackers, so which we also explode during festivals. It works on the explosive combustion of substances. Right now, so that is the principle there. So when a cracker is ignited with a burning matchstick, what happens? The chemical in yes.
So usually people dry firecrackers in the sun before they burn it. So why do they do that?
Why do we do that? So that it burns properly. So that if there's some moisture in it, moisture is evaporated. Water is evaporated from it. Okay, now.
So, but in the first place, why would it have moisture?
See, sometimes while if it is not stored properly, then that might be the case. Also, there's a thread attached to the firecracker. There's a thread attached to the firecracker, which we light using the matchstick. So if that thread is not dry, if it is not dry properly, or it is somehow there's some moisture in it, and in the like you asked why there will be moisture. Usually, what will happen if it is not stored properly, then there will be some moisture present in it. If it is stored properly, then there won't be any moisture in it. So that is the reason sometimes people usually dry it in the sun. Okay.
Yes, sir.
So when you will be lighting it using a matchstick, the chemicals present in it will undergo a sudden combustion, will go under a rapid combustion, and it will produce lots of heat, light, and a large volume of gas will be released from it. The gases that are produced are heated by the heat that is coming from the reaction. See that this is your a typical firecracker. There are chemicals present in it. As soon as you lit this thread, what happened? The chemicals started to go through a rapid combustion. And as they went through the rapid combustion, they started to release extreme amount of heat. Releases high amount of heat. And also note this thing down, that a large volume of gas will also be coming out of it. Right now. So the gases produced are heated. These gases that are produced, they are heated by the heat evolved in this rapid reaction. And the hot gases, they expand rapidly and causes an explosion. And thereby it produces a loud sound. Also, in some cases, apart from this example of firecracker, an explosion can also take place if pressure is applied on the cracker by hitting it hard. You guys know that. For example, if there's a road roller, you understand what a road roller is? Road roller is used to metal the roads. Right now, when roads are constructed, then road rollers are used. So for example, if road roller were to run on a firecracker, in that case also what will happen? Lots of pressure will accumulate. In that case also it can explode. Are you guys getting it?
Yes, sir.
Huh? You might have observed that sometime. If pressure is increased, then in that case also it could be a explosion. So hope that is also clear. Now we are going to talk about fuel. Okay, now? Okay, we learned about fuel previously also. Who will define to me? In the previous chapter, we learned about fuel. Yes, Sandas, Khadija, Chakrika, Gauri, Alif. Also, you guys are required to turn your cameras on in the class. Yeah. Chakrika, define fuel.
Petroleum.
No, petroleum, that is an example. No? Like, what is a fuel?
Basically, which is used to produce heat or power by burning.
Correct. Right now.
Yeah.
So a material which is burned to produce heat, it is simply called as fuel. Okay. A material burned to produce heat, that is called as fuel. Then uh, we have so many common examples of fuel now. We have examples of kerosene, petrol, diesel, natural gas, biogas. We learned about so many of them. Wood, coal, petrol, biogas, CNG, kerosene, diesel, etc. We learned about so many of them. Now, the the heat energy produced by burning of fuel, we can use it directly to cook the food, or it can be used for running motor vehicles, and it can be used for running motor vehicles, and also it can be used to run the machines in the factory, or the heat uh, coming out due to burning of a fuel can be used to run more, can be used to produce electricity also at the thermal power stations now. So uses of fuel are as follows: either it can be used for cooking, or either it can be used for operating the factory machines, or it can be used for generation of heat. Okay, anyone has an you guys got you guys know that how thermal power plants work? Anyone knows this? How thermal power plants work?
No.
See, basically, a thermal power plant works by using the heat energy produced from the combustion of fossils. So, whenever a fossil fuel will be burned, say for example, uh, let us take a simple setup to make you understand this. Okay, now, say there's a big container. There's a big container in which you have taken water. Okay, and this water is being heated up. In order to heat up this water, fuel is being used. Okay, now this is being heated using fuel. So some fuel will be burnt in order to heat up this water. And due to heating of water, we know that steam will be produced. So steam is produced. So now using this steam, what you can do, you can rotate the turbines. Okay, now say that you have got a turbine here. Say that no, you have a turbine. So using this steam, the turbines can be rotated. All right, now that is an alternative. So the steam that is coming out of this boiling water, it can be used to rotate this turbine. And as the turbine will be rotating now, thereby this motor will also rotate. And this motor will rotate, and in turn, it will produce electricity, and those electricity will be stored. Electricity is stored. So that's how a thermal power plant basically works. Are you guys getting it? Thermal power plant basically works by utilizing the heat energy generated from the combustion of fossil fuels to produce steam. And steam in turn will be running the turbine. It will be running the turbine. This is turbine. It will be running the turbine to produce electricity. Hope you guys have understood that. So that is the
Yes.
basic mechanism of it. Produces heat to produce heat, and then to use it to rotate the turbine. You guys might be aware of this. How like the how steam engines were working. What is the principle behind the working of steam engines? It's also works on somewhat the same principle. A steam engine is basically a heat engine that performs mechanical work using steam as its working fluid. I mean to say that basically the steam engine will be using the force produced by the steam to push the piston back and forth inside a cylinder. You guys know about piston? In engines, you will find piston. Are you guys getting what I'm trying to say? What is piston? Let me show an image of it so that you guys get a clear idea. See, this is a piston. Where do we find this? It will be found in the engines of motorbikes, in the cars or different vehicles. So how does a car run? It is because of the movement of the piston, right now. So the fuel that you put in the vehicle, that fuel is basically utilized to move this piston, right now. So the engines that are present in the steam engines, there also we had the piston. So this steam pressure was used to move that piston, right now. So it was used to move it backward and forward, and hence in that manner steam engines were working. Hope you guys are getting an idea of what I'm trying to say. Okay. So that is the thing. Now let us learn about what is an ideal fuel. Now you guys tell me, what are the characteristics of a good fuel? What makes a fuel good? Yes.
Should not produce any smoke.
Okay. It should not produce any smoke. Then
It will not produce remaining.
okay.
It should have a high calorific value.
Very good.
Easy to transport.
Good.
Should not leave any residue behind.
Very good. Should not leave any residue.
Easily available.
Easily available. It should be cheap, right? And easy to transport. And the most important thing, it should have a proper ignition temperature. Right now, proper ignition temperature, no residues, comma, no toxic gases should be produced. It should be cheap. It should be readily available.
No bad odor.
No bad odor. Very good. No bad odor. Right now, no bad odor, and should be easy to store and transport. Store and transport. So that is what an ideal fuel is right now. But in nature, do we have such a fuel? Do we have any fuel that can be considered to be an ideal fuel? No. Actually, no. Note that perhaps there's no fuel which can be considered. Yes, Alef. Which one? Give an example.
The LPG.
No. Is it cheap?
Natural gas.
CNG.
CNG. See, is it available everywhere?
So natural gases.
Talking about like natural gas. Like natural gas, is it cheap or is it available everywhere?
No, sir.
No. If we go by the requirements of an ideal fuel needs to have a high calorific value. It should burn easily and at a moderate rate. One more thing, it should burn easily at a moderate rate, meaning that it should neither burn too fast or neither it should burn too slow. Right now, that means that it burns neither too fast nor too slow. So in nature, we don't have got any such fuel which can be considered as an ideal fuel. All right, now, so there isn't any fuel that can be considered as an ideal fuel. So note that thing down, that perhaps there is no such fuel such as an ideal fuel, because no fuel will meet all the required criteria mentioned here. Hope you guys are getting it. Okay, now next, learn about calorific value and fuel efficiency and efficiency of a fuel. So all the fuels produces heat on burning. That is obviously all the fuels are going to produce heat. However, the amount of heat produced is not same. So different fuels produces different amount of heat on burning. Different fuels produces different amount of heat on burning. Getting it, guys?
Yes, sir.
Some fuels will be producing more, whereas some fuels will be producing less amount of heat. So we see that the efficiency of a fuel is expressed in in calorific value. The efficiency of a fuel is expressed in calorific value. Right now, then question comes, what is calorific value? So we say that it is the amount of heat energy produced on it is the amount of heat produced by the complete combustion of 1 kilogram of a fuel under the normal conditions. So you have any fuel, you have 1 kilogram of fuel. If you burn it, and the amount of heat that will be coming out after burning it under the normal conditions, that is called as the calorific value of the fuel. And how do you represent it? It is represented in a unit called as kilojoule per kilogram. How much of kilojoule of energy is released upon burning 1 kilogram of that fuel? Kilojoule or joule are the unit of energy. Keep that in mind. Joule is the smaller unit, okay na, and kilojoule is the bigger unit.
Okay.
Good. Okay, look at the given table here, by the way. Kilojoule. 1 kilojoule, joule in short is represented by the letter capital J, and this is capital K and capital J. 1 kilojoule equals to 1000 joule. Keep that thing in your mind, okay? Now from the table, what can you observe? Like, which fuel has got the highest calorific value?
The hydrogen gas.
Yes.
Hydrogen gas, no? Good. While cow dung has got the lowest calorific value. Okay. Now, what are the factors that is going to determine the calorific value? Tell me, what factors determines the calorific value of a fuel? There are different things that will be determining. Okay, now, like it will be determining the factor that will determine the calorific value of a fuel is the composition of that fuel, right? Or the amount of moisture content in that fuel. So amount of moisture content and its composition will determine the will determine the amount of heat it will be giving out. Hope you guys are getting that. Okay. So cow dung, wood, coal, their calorific value are given as follows. Okay. We're going to do some questions, but note that down. Moments ago, what we have learned that whenever any 1 kilogram of fuel is going to be burned, also it's not like just you have littered it. It should completely burn. It should be burnt completely. Right now, like you are burning 1 kilogram of kerosene, so nothing should be left, not even a drop. Okay, then you will be able to correctly calculate its calorific value. So say that when 1 kilogram of kerosene is burnt, kerosene is burnt completely. Thereby we saw that around 45,000 kilojoule of heat is released, isn't it? 45,000 kilojoule per
Yes.
kilogram. Kilojoule per kilogram, that much amount of heat is given out. So we say that the calorific value of calorific value of kerosene is 45,000 kilojoule per kilogram. If this much amount of heat is given out, so its calorific value is said to be 45,000 kilojoule per kilogram. Okay. Now you guys tell me, suppose if you were to have 2 kilogram of the kerosene right now, and say that in that case 90,000 kilojoule of heat is produced. So what will be the calorific value?
Can you repeat?
Question is 2 kilogram of kerosene is burnt completely. Upon burning 2 kilogram of kerosene completely, 90,000 kilojoule of heat was released. What is the calorific value? It's such a simple question. Yes. See, in order to calculate the calorific value, the formula to find this is out.
45,000.
Exactly, it is going to be same right now. So it is heat released upon the weight of the fuel. Okay, now that is basically mass of fuel. Mass of fuel burnt. Okay. In the given question, sample problem 1, 4.5 kilogram of a fuel was completely burnt and heat produced was measured to be 1,80,000 kilojoule. You had to calculate the calorific value of the given fuel. So here, simply the amount of heat produced has been multiplied by the total mass of the fuel burnt. Thereby you got it. Okay, do one question. Okay, the question says that, say you have now you are burning, let's say 5.5 kilogram of fuel is burnt. Upon complete combustion of 5.5 kilogram of fuel, let us say that 1,65,000 kilojoule of heat was released. You have to find the calorific value. You have to find the calorific value. You guys understood the question? Chakrika, Sandosh, Khadija, and Aleph, Gauri.
Sir, can you repeat?
Question is that upon burning, listen carefully, upon burning 5.5 kilogram of fuel completely, 1,65,000 kilojoule of heat was released. What is the calorific value of that fuel?
I got the answer.
Answer it in the chat box. Everyone has to do it.
Like, what was the question?
Okay, I'm repeating the question. Question says that upon burning 5.5 kilogram of fuel, the amount of heat released was 1,65,000 kilojoule. You have to find out what is the calorific value of that fuel. The formula required is heat released upon mass of the fuel burnt. Chakrika, the answer you have given is not correct.
So can I try again?
Yeah, sure.
Sir, did you receive my answer?
Give me a minute. The answer, what have you answered? Yes, Sandhu, so your answer is correct. Write the unit also. Don't forget to write the unit. Gauri, your answer is not correct. Khadija,
Yes, sir.
okay, yeah, your answer is correct, but you haven't written the unit. What is the unit of calorific value? It's kilojoule per kilogram now. Also, Khadija, that is not the standard way to write the answer. Okay, no, Khadija.
So
Like to
I should write
denote
the
thousand, don't be
answer
at it.
as kg, kj.
Yeah, you have to write the answer in this term. No, use the unit.
Sir, is it correct?
Yeah, Chakrika, that is correct. Good. Sundus, uh, correct your answer. Khadija, you also correct your answer. Alif, it is not going to be zero. How can it be zero? Like some amount of heat is going to be produced. How can it be zero?
So
Okay,
the
Alif.
answer is wrong.
No, your answer is correct, but the unit, you have to mention the unit also, na? This unit should also be mentioned.
Like, so we have to mention all the unit kg, sorry, kj.
Per kilogram. Kilo, joule per kilogram. Whatever number you are getting after the number, write this. Kilojoule per kilogram. Okay, let me explain this one. See, the formula required was heat released upon mass of the fuel burn. How much of heat is released? 1,65,000 kilojoule. Right now. And mass of fuel burnt is 5.5 kilogram. You remove the decimal,
Sir,
one,
sir, my
yeah.
answer is correct now. Can you check?
Yes, Alif.
Is my answer
Now it
correct?
is correct. Now it is correct. Very good. Very good. So
Okay.
you solve it, you will be getting how much? This would be your answer.
30,000.
Kilojoule per kilogram.
30,000 kilojoule.
Yeah, I saw your answer. It is correct, Alif. Okay, now those of you who are getting this answer, that is great. And those who got it wrong, please correct it. Hope it is clear to everyone.
Yes.
Is it? Okay. If anyone has any doubt in it, please do let me know. Okay, now? Okay. Now we are going to learn about the history of matchstick. Okay, now? Like what is the history of matchstick and how it was basically invented? What is the composition of the matchsticks? Getting it, guys? One of you, please read the given paragraph. Gauri, you would like to read this?
Me?
Yeah.
Okay.
Read
The
this.
history of mastic is very old, more than 5,000 years ago. A small piece of pine wood dipped in sulfur were used as a matchsticks in ancient Egypt. The modern safety matchsticks were developed only about 2,000 years ago. A mixture of, so what is this? Antimony.
Antimony trisulfide.
So can you zoom it up? But okay.
Yeah, sure, sure.
Antimony, trisulfide, potassium,
Trisulfide. Trisulfide.
trisulfide,
Mhm.
potassium chloride, and white phosphorus with some glue and starch, and was applied on the head of match made with a sustainable wood.
Suitable,
When
suitable.
suitable wood, when stuck against a rough surface, white phosphorus got ignite due to the heat of friction. This starts the combustion of the match. And however, with white phosphorus provides to the dangerous both for the workers involved in the manufacturing of the matchsticks and for the users. These stays the ahead of the safety match contains only antimony, trisulfide, and the potassium chloride. The rubbing surface was powdered glass and a little red sulfurous, which is much less dangerous. When the match is stuck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with uh, potassium chloride in the mastic had to produce enough heat to ignite antimony trisulfide and start to combustion.
The history of matchstick is not very new. It's very old. It's very old. Okay, no? And we learned that it is how much old? It is almost 5,000 years old. Right? Basically, we are more concerned with what is the composition of the matchstick and what is the principle behind the working of a matchstick. You have to look at the tip of a matchstick. The tip of this matchstick, it had a coat of antimony trisulfide. This red coating that you see on matchstick, earlier it had a coating of antimony trisulfide. It's a chemical. Apart from that, potassium chloride was also there, starch and gum was also used in it. So here it says that a mixture of antimony trisulfide, potassium chloride, and white phosphorus with some glue and starch was applied on the head of match made of a suitable wood. Right now, so you took antimony trisulfide, then we had potassium chloride. Apart from this, starch was also used. Then gum was also used to prepare a mixture and paste it onto the tip of a matchstick. And they could be ignited when they are stroked between folded sandpaper. If you take a folded sandpaper and if you were to strike in that, it will catch fire. So the basic principle behind the working of a matchstick is basically friction. Right now, the matchsticks that we use today are friction matchsticks, and it is very different from the matchsticks that were used 5,000 years ago. The 5,000 years ago, this matchstick consisted of potassium also. Phosphorus was also used in this. Right now, when this matchstick was struck against a rough surface, white phosphorus got ignited due to the heat of friction. Right. Also, it is mentioned that white phosphorus was also used in this earlier. Okay, now let me write that also. White phosphorus was also earlier used, but now it is white phosphorus is not used. Okay, now no longer used in today's matchsticks because it posed a risk to the health of the person who would be igniting it. Right. So today only we make a mixture of antimony sulfide, potassium chloride, starch, and gum. Okay, na? So once it is struck against a rough surface, what will happen? The match will start to catch fire. So white phosphorus, basically in this, white phosphorus got ignited due to the heat of friction. And we have learned previously, like in the example of spontaneous combustion, we learned about white phosphorus now. White phosphorus catches fire on the room temperature, but here it's in a mixture, but still it's a very combustible substance. So what is combustible in a matchstick that we used earlier? It is white phosphorus. Getting it, guys? But nowadays white phosphorus has been replaced with something else. It has been replaced with lead dioxide. So the matchsticks that we use today are the friction matchsticks, and they were invented by the matchsticks that we are using today. They are invented by an English chemist whose name was John Walker. Let me write this. Modern matchsticks. They were invented by John Walker. He was the person who invented this in the year 1827. Although year is not important, but just know the name of this person. He was a chemist. Chemist is a person who deals with different type of chemicals, who studies chemicals, who does research on chemical substances. Now, as the time passed by, what happened? This white phosphorus was replaced with lead oxide. white phosphorus got replaced by lead dioxide, which did not pose much harm as compared to the white phosphorus. Okay, no. Also, earlier when these sticks were burnt, now it produces sound also. It produces a good amount of sound, but nowadays it does not produce that much of sound. So also you might have seen, like on the matchbox, it would be written as safety matches, right? Now, earlier it was not considered as a safety matchstick because it could sometimes harm the person also. The chemicals used in it were not safe. These days, the head of the safety matches contain only antimony trisulfide, potassium chloride, only that much. Now you'd see on the match boxes there would be a rubbing surface also. A rubbing surface is also provided on the matchstick. On the side you will find this. So what is this? Yeah. So here it basically says that the rubbing surface has powdered glass and a little amount of red phosphorus, which is much less dangerous as compared to the white phosphorus. So when the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus, and thereby that also helps in igniting it. This immediately reacts with potassium chloride in the matchstick head to produce enough heat to ignite antimony trisulfide to start the combustion. So let me just quickly summarize what is going on here. See, right now we are talking about the safety matchsticks, safety matches that we use today. So you have a matchstick. The head of this matchstick is made up of only these chemicals. It only consists of antimony trisulfide, it also consists of potassium chloride, only these two things are found in it, while the white phosphorus has been replaced by lead dioxide. Okay, now plus lead dioxide. Is that much clear to everyone? The
Yes,
tip of
sir.
the matchstick consists of these chemicals today. Now, what about this hard surface on the matchbox? So this is powdered with some glass. There will be fine glass particles in it. For friction, there will be fine glass particles in it. Okay. Apart from that, we have coated it with a little amount of red phosphorus also. So this consists of glass powder plus red phosphorus. Now let us understand about the mechanism here. How does it basically work? So as you rub the matchstick on this surface, thereby what happens now, due to rubbing, heat will be generated due to rubbing, and some of the red phosphorus it converts to white phosphorus. Getting it, guys? It
Yes,
converts
sir.
to white phosphorus, and in return what this will do, this white phosphorus will be immediately reacting with the potassium chloride found in the tip of the matchstick. So this converts to white phosphorus, and now white phosphorus reacts with potassium chloride. So in this manner, a matchstick ignites. Okay, now. So, and it like the reaction of white phosphorus with um, potassium chloride uh, produces enough heat to start the combustion. Hope you guys have understood the working of this matchstick. If there's any
Yes,
doubt
sir.
in it, please do ask me. Sandus, you understood this? Gauri,
Yes,
Shifika,
sir.
Khadija, and Alif? Good.
Yes.
Yes, sir.
That is the thing about the modern matchsticks, right? Now, also, like earlier, if you were to talk about the matchsticks, Earlier, people were selling it individually, like it was not produced on a wider scale. Uh, It was only in the year 1855 that mass production of matchsticks started in several factories. Yes.
If sir told that if she rub the match into a rough surface, it will ignite. If we rub the match with the rock, it will ignite.
It will catch fire. You're saying that if we rub matchsticks on a rock, then it will catch fire.
Okay.
Is that your question?
Yes, sir.
Okay. Like if you rub matchsticks on rocks, then what will happen? In certain cases, that can also catch fire. You know, in certain
Okay.
cases, that can also catch fire. You know, that is not a very surprising thing, right now. But although it will not work every time. Although it is not going to work every time, because you need to have red phosphorus and glass powder. Glass powder is basically used to make the surface rough.
Sir, frictional
Yeah,
force is there, so the heat is produced, right?
heat is going to be produced right now, but like it will not be a very effective method to burn it right now. No, because not that much amount of heat will be produced. Friction is going to be there, but not that much amount of heat will be produced. So it might not burn properly. That is the thing. That's it for today. In next classes, we are going to learn about few more things. Right now, we are going to learn about ignition temperature. A little bit we already learned about this, and we are going to learn about fire. What are the safety measures regarding fire? How do you control the fire? Okay, now what is the working principle of a fire extinguisher? How does it work? Those things are left to discuss. We'll be doing that in the next class. Okay, so that's it for today.
Bye, sir.
Thank you.
Yes, bye.
So I have a doubt.
Yeah, Chakrika.
Sir, is LPG more expensive than CNG?
Is LPG more expensive than CNG?
Yes, sir.
See, I think that I don't think that CNG is much expensive than LPG. I think CNG is generally cheaper than LPG. CNG generally we see that it is cheaper than LPG. Okay, no.
Yes,
Although
sir.
if you were to talk about the calorific value or the amount of energy that is produced, there we see that LPG can be more cost effective than the natural gas. Also,
Yes.
local prices varies. Local price will fluctuate. Okay, no?
Oh, okay. Sir, I have two more doubts. Is it possible for you to clear it right now, or can you do it in the next class?
No, we can do it until the next student does not join. Okay, no? Yeah.
Okay, sir. Sir, the other doubt is that in the fractional distillation of petroleum, where do the vapors of the highest boiling point condense?
Where do the vapors of highest boiling point condense?
Yes, sir.
Okay.
In the
So we
fractional distillation of petroleum.
okay, I got it. See, what is going to happen? You are going to have different vapors would be coming out of the fractional distillation of petroleum
Yes, sir.
in this refinery. See,
Yes, sir.
like from the topmost chamber, we have learned that uh, gas will be collected. Gas will be
Yes,
collected.
sir.
Then petrol will be collected. Right now, naphtha will be collected. Naphtha is used to make different chemicals. Then kerosene. Then we have diesel. Then we have some other fuels. Now, some other fuels are collected. In the bottommost, we have substances like bitumen, right? And here the temperature was close to around 400 degrees Celsius. So once every component would have separated from it, fuel is separate, different fuels, diesel, kerosene, naphtha, petrol, gases. When all of them gets out and all of them condenses on the respective chamber, So in the bottommost, you would be only left with bitumen and some other substances now. So they will collect at the bottommost simply because rest have evaporated and condense at different chambers. So it
Yes.
is like it will be left at the bottommost chamber, and you can simply take it out in that
Yes.
manner.
Yes. So
Okay,
then type of what is the type of coal that can serve as a good heating fuel for domestic purpose?
for the domestic purposes. For the
Yes, sir.
domestic purposes, usually it would be better to use subbituminous, like anthracite. For people, it will be a little bit expensive, but not as expensive as petrol or diesel. But if you had the only option to use coal only, then people should be most preferably